Hi there, my name is Dimitris Charalambidis, and in this video, which relates to the absolute value equations, we will work together some exercises. So let's put a proper title and start already. Worked examples on absolute value equations. Let's go. Let's begin with number 2. X plus 4 equals 9. We know that we have this case. Absolute value of x equals to theta, where theta is a positive number, means that we have to split it. X equals theta or x equals negative theta. And of course, it's not just about the x, it's always about the expression inside the absolute value. So in this case, all I'm going to do is split it like that. X plus 4 equals 9, or x plus 4 equals to negative 9. I will need to solve these two separately. 9 minus 4, so x equals 5, or minus 9 minus 4, so x equals negative 13. Then let's go to number 4. 2x minus 1 equals 6. Another thing that we have said already, either in class or in one of my videos, is that we never start applying any process unless we have it in the needed form, which is absolute value of something equals to a number. So what should I do in this case? I should solve first for the absolute value. Okay, so this means that I should begin by dividing both sides by 2, since I want these 2's to be simplified. So I'm left with x minus 1 equals 3, which means that I again need to split it. X minus 1 equals 3, or x minus 1 equals negative 3. So this means that x equals 3 plus 1, which is x equals 4, or x equals negative 3 plus 1, which is x equals negative 2. Let's go and then solve number 6. 5x minus 2 in an absolute value is equal to 3x plus 6. Remember, that's the case in which we need to set up restrictions first. So I'm going to go here and I'm going to set my restriction. Regarding this restriction, since the left-hand side is, and the left-hand side is this, but since this is an absolute value, and we know that the absolute value stands for distance, and we know that distance is always greater or equal than 0, by applying this transition, we get that the left-hand side should always be greater or equal than 0, which further means that since this left-hand side is equal to the right-hand side, this means that since 1 is greater or equal than 0, the other should be also greater or equal than 0. So our restriction would be this. 3x plus 6 should be greater or equal than 0. By solving for x, we get that x should be greater or equal than negative 2. We'll keep that for now because we're going to use it in the end. Then we will proceed normally. 5x minus 2, the expression inside the absolute value, should be equal to 3x plus 6, or 5x minus 2 should be equal to the opposite of that. So 5x minus 3x equals to 6 plus 2. So 2x equals 8. So x equals 4. Or 5x minus 2 is minus 3x minus 6, which means 5x plus 3x should be minus 6 plus 2. 8x equals negative 4. X equals minus 4 over 8, which means that is equal to minus 1/2. Now I have to check whether both or one or none satisfy my restriction. My restriction was that x should be greater or equal than negative 2. So we are definitely fine with 4. Negative 1/2. Is it greater or equal than negative 2? Yes. So both of them should be accepted. Let's go now to solve 14. Absolute value of 2x minus 5 should be absolute value of x plus 3. We know from theory, or we should have known from theory, that absolute value of x is equal to absolute value of y, means either that x and y are the same or the opposites. And again, it's not about just the x's, but math being a rather symbolic language, it's about the expressions inside the absolute values. So let's use this. 2x minus 5 is x plus 3, or 2x minus 5 is minus x plus 3. So 2x minus x equals 5 plus 3, so x is equal to 8. Or 2x minus 5 is minus x minus 3, so 2x plus x equals 5 minus 3. 3x is 2, so x equals to 2/3. Both should be accepted. Let's see what else do we have. Let's do 20. 3x minus 2 plus 5 equals 14. And of course, while I'm doing them, I cannot pause myself, but you can pause the video. While I'm doing them, you can pause the video right now. You can try to solve it by yourselves and then return back to see the solution. That would have been more proper way to self-study. Anyways, now, we've said it before. We do not start anything unless we bring that to the form. Absolute value of x, without coefficients, without nothing, equals to a number. Now, how can we do that? It's about properties of equation, of equality. If we cannot do something which will directly isolate the absolute value, we need to begin by trying to isolate the term that contains the absolute value. And that term is this. So we should begin by isolating that, which means that we should get rid of 5. But 5 is being added to the yellow one. So we should subtract it from both sides, or we should simply, as you know that better than me, take 5 from the left to the right, so it should change that. Its sign is 9. I need to have the absolute value by itself, so I should divide both sides by 3. Let's do that in details. I did that because these are cancelled out. So absolute value of x minus 2 is equal to 3. And now I can apply my theory. So x minus 2 is 3, or x minus 2 is negative 3, which means that either x equals 3 plus 2, so x is 5, or x is negative 3 plus 2, x is negative 1. Both should be accepted. Let's see what else should we do. Okay, let's try and do 27. Absolute value of x minus 3 minus 4 should be 5. Remember, everything is symbolic in math. It's not about x, it's not about x minus 5, it's about symbols. And we have seen that absolute value of an expression A is equal to B, where that B is positive, means that either that is equal to B or equals to negative B. So what I'm going to do is that by thinking that we have this absolute value first, I'm going to split that into two different cases. The expression inside of that is either equal to 5 or the expression inside of the yellow absolute value should be equal to negative 5. Now I need to solve each one of these separately. But again, we cannot start initializing any process unless we have it as a single absolute value equals a number. So even here, I should do x minus 3 is 5 plus 4. So x minus 3 is 9. And now I can split that. So x minus 3 is 9 or x minus 3 is negative 9, which means that either x equals 12 or x equals negative 6. I'll do the same process to the other one. X minus 3 equals minus 5 plus 4. So x minus 3 is minus 1. So I'm going to hold on. An absolute value can never be negative since absolute value is distance. So absolute value is negative would have meant that distance could be negative, which cannot. So in this case, we just say no solutions. Is there any harder than that? No, that's all then. You can see on the left side of your screen more exercises. You can try and work them if you want. We worked enough exercises to have a first idea of how we proceed with absolute value equations. If, however, you face any difficulties, you have any questions, please feel free to share them in the comment section below this video. As always, thank you for your time.